Dear children, now let us solve the questions of the chapter Polynomials which are given in the Model Question Paper 2025-26. Now you take the Model Question Paper 1, first question. In the figure, the number of zeros of the polynomial y is equals to p of x is. Here you observe the figure. This is the x-axis and the graph intersects the x-axis at 4 points. These are the 4 points of intersection of the graph with the x-axis. So, number of zeros equals 4. Number of zeros equals 4. Option C is the answer. Then you take the second question. If the zeros of the polynomial p of x equals x square plus 3x plus k are reciprocals to each other, then find the value of k. Here the two roots are alpha and beta. One root is reciprocal of the other, means alpha and 1 by alpha are the roots. Here alpha equals alpha and the other root beta is equals to 1 by alpha. So let us take the quadratic polynomial first. X square plus 3x plus k. Here a equals 1. Coefficient of x square a equals 1. B equals coefficient of x, that is 3. This is the coefficient of x, and c equals k. Then if alpha is equals to alpha, then beta is equals to reciprocal alpha, that is 1 by alpha. You know that alpha beta is equals to c by a. Alpha into beta is 1 by alpha equals c is k by 1. These two cancels. 1 is equals to k, so you got k is equals to 1. Question number 3. Write the quadratic polynomial whose sum and product of the zeros are 2 and minus 8 respectively, and hence find the zeros of the polynomial. This is 2 marks question. Now let us write the sum and the product. Alpha plus beta. Sum is alpha plus beta. Sum is given. Sum is 2. And product of the roots alpha beta is equals to minus 8. Then the quadratic polynomial is x square minus alpha plus beta into x plus alpha beta, that is x square minus 2x and minus 8. This is the quadratic polynomial. Now we have to find the zeros. So take the sum and the product PQ. PQ equals x square into minus 8 minus 8x square, and the product of the roots P plus Q is the middle term, that is minus 2x minus 8x square. Here the signs are different, and the product is having negative sign and the bigger factor is having negative sign, that is the sign of the middle term, that is minus plus. And 4 2s are 8, so you take 4x and 2x. Minus 4x plus 2x is minus 2x, and minus 4x into 2x is minus 8x square. Then you take here x square minus 4x plus 2x minus 8 equals 0. We have then out of these two remove common. X into x minus 4 plus out of these two 2 is common, 2 into x minus 4 equals 0. Then you write x minus 4 into x plus 2. x plus 2 equals 0, then x minus 4 equals 0, or x plus 2 equals 0, x equals 0 plus 4. Transfer this minus 4 to the RHS. Then x equals 0 minus 2. You got x equals 4 or x equals minus 2. Then the roots are alpha equals 4, beta equals minus 2. Fourth question. If alpha and beta are the zeros of the quadratic polynomial p of x equals x square plus 3x plus 1, then find the value of 1 by alpha plus 1 by beta. First one. Second one, alpha square beta plus alpha beta square. For this, we have to find out the sum of the roots alpha plus beta and product of the roots alpha beta. Now you take down x square plus 3x plus 1. Then write the values of a, b, c. A equals coefficient of x square 1, b equals coefficient of x, that is 3, and c equals 1. Then write. Now let us find alpha plus beta. Alpha plus beta equals minus b by a equals minus 3 by a is 1 equals minus 3. Then alpha beta is equals to c by a, c equals 1, a equals 1, 1 by 1 equals 1. Now you take this one, 1 by alpha plus 1 by beta, 1 by alpha plus 1 by beta. In the denominator, take the LCM of alpha and beta. LCM of alpha and beta is the product of alpha and beta, that is alpha beta. And next 1 into beta is beta plus 1 into alpha is alpha equals beta plus alpha is nothing but alpha plus beta, which is equals to minus 3, and alpha beta is 1, minus 3 by 1 is minus 3. Then you take this one, alpha square beta plus alpha beta square. This is first one. Then you take the second one, alpha square beta plus alpha beta square equals, right, alpha beta. Here alpha beta is common into alpha plus beta equals alpha beta is, here if alpha beta is removed, in the bracket you are going to get alpha plus beta, because alpha beta into alpha is alpha square beta, and alpha beta into beta is alpha beta square. So if alpha beta is removed common, in the bracket you will get alpha plus beta. Then what is the value of alpha beta? Alpha beta value is 1 into alpha plus beta is minus 3. 1 into minus 3 equals minus 3. So you got both 1 by alpha plus 1 by beta is also minus 3, and alpha square beta plus alpha. Next let us take the questions from the model question paper 2. First question, the degree of the cubic polynomial is. The degree of the cubic polynomial is 3. Degree of cubic polynomial is 3. Then the second question, write the zeros of the polynomial y equals p of x in the given graph. Here you observe the graph. It intersects the x-axis at 2 points, 1 and 2. These are the 2 points at which the graph intersects the x-axis. Then What are the coordinates here? This is 2, this is minus 1. 2 and minus 1 are the zeros. Zeros of y equals p of x are 2 and minus 1. 2 and minus 1 because the graph intersect the x-axis at 2 and minus 1. Then you take the third question. The question is, if one of the zeros of the polynomial p of x equals to x square minus 8x plus k plus 1 is 7 times the other, then find the value of k. Here if you take one zero is alpha, other zero is 7 times alpha. So alpha and 7 alpha are the two zeros. Alpha equals alpha and beta equals 7 alpha because it is given that one of the zero is 7 times the other. So let us write the polynomial 2x square minus 8x plus k plus 1. One of the zero is 7 times the other. So if you take, write the values of a, b and c. A is the coefficient of x square, that is 2. A equals 2. B is the coefficient of x. B equals minus 8 and C equals, C is the constant which is equals to k plus 1. Then it is said that one root is 7 times the other. One zero is 7 times the other. Means if alpha is one root, the other root is 7 alpha. So you can take alpha is equals to alpha, beta is equals to 7 alpha. To find k, k is in C, so you take the product of the root. Let us take sum and product of the roots. Write alpha plus beta equals minus b by a equals minus of minus 8 by 2. 2 ones are. Here you write alpha only plus beta 7 alpha equals minus b is minus 8 by a is 2. Alpha plus 7 alpha is 8 alpha. 8 alpha is equals to 8 by 2. You can cancel 8. So you got alpha is equals to, here 1 is remaining, 1 by 2. Then beta is equals to 7 alpha, which is equals to 7 into 1 by 2 equals 7 by 2. Now you take the product of the roots alpha beta. Alpha beta is equals to c by a. Alpha is 1 by 2. Beta is 7 by 2. And c is k plus 1 by a is 2. And it becomes 1 into 7, 7. 7 by 2 into 2 is 4. 7 by 4 equals, or otherwise here only you can do, cancel this 2 into 7 by 2 equals k plus 1. You got that k plus 1 equals 7 by 2. Do the cross multiplication. 2 into k plus 1 equals 7. 2 into k is 2k and 2 into 1 is 2 plus 2. equals 7. 2k equals 7 minus, transfer this 2 to the RHS, it becomes 7 minus 2. Then 2k equals 5, k equals 5 by 2. Got the value of k equals 5 by 2. Now let us come to the model question paper 3. First question, the 0 of the polynomial p of x equals 5x plus 3 is. It is a linear polynomial which is in the form ax plus b. For linear polynomial, x equals what? Minus b by a. X equals minus b by a. Here a is 5, b is 3. A equals 5, b equals 3. Then x equals minus b by a. X equals what? Minus 3 by 5. X equals minus 3 by 5. Then option A is the answer. Or otherwise, you can follow the other method. Take 5x plus 3 equals 0. Then 5x equals minus 3. X equals minus 3 by 5. This is the method by using the formula. This is by taking polynomial equals to 0 to find the value of the 0. Next, second question. In the quadratic polynomial f of x equals x square minus 9x plus 10. Find the value of f of 1. Write the polynomial f of x equals x square minus 9x plus 20. F of 1 equals 1 square minus 9 into 1 plus 20. Here in the place of x we have to put 1. That equals 1 square is 1 into 1, 1 minus 9 into 1 is 9 plus 20. Then you can have 1 plus 20 as they are having positive sign. 1 plus 20 which is equals to 21 minus 9. So you got f of 1 equals 21 minus 9 which is equals to 12. F of 1 equals 12 you got. Question number 3. Find the zeros of the quadratic polynomial p of x equals 6x square minus 7x minus 3. Relationship between the zeros and the coefficients. Here write the quadratic polynomial p of x equals 6x square minus 7x minus 3. We have to find the zeros. To find the zeros, take let 6x square minus 7x minus 3 equals 0. By using the splitting the middle term, we can get the zeros here. Take sum and product. 6x square into minus 3 is PQ. Product. PQ equals 6x square into minus 3 equals 6 3 is 18 minus 18x square. Then P plus Q is the middle term, that is minus 7x. Minus 7x. Minus 18x square. Minus 18x square is to be expressed as a product of two factors in such a way that their sum must be equals to minus 7x. Here the product is having negative sign, so the factors are having different sign, and the greater factor is having negative sign, that is minus and plus. And in which table 18 is there? 9 minus 9x plus 2x. The product of these two is minus 18x square, and minus 9x plus 2x is minus 7x. Now you write 6x square as it is, and minus 7x is equals to what? Minus 9x plus 2x minus 9x plus 2x, and write this minus 3 as it is, equals 0. Out of these two, remove common. 6 and 9 are in the table 3, the HCF is 3, and x square and x. Out of x square and x is common. So 3x is common. Write it outside the bracket, and in the bracket, what is remaining here? 3 2s are 6. So 2 x into x is x square 2x. So 3x into 2x is 6x square minus 3x into what is 9x? 3x into 3 plus here 2x minus 3. Out of 2x minus 3, 1 is common. Other than 1 is not there. So 1 is common, and in the bracket write 2x as it is minus 3 as it is, equals 0. So you got 2x minus 3 common bracket. Take it as a common. 2x minus 3 into 3x plus 1. 3x plus 1 equals 0. Equate 2x minus 3 to the 0 and 3x plus 1 to 0. 2x minus 3 equals 0, or 3x plus 1 equals 0. 2x equals 0 minus 3 becomes plus 3 if it is transferred to RHS, plus 3, or 3x equals 0 plus 1 is transferred, it becomes minus 1. You got 2x equals 3, or 3x equals minus 1, then x equals 3 by 2. Transfer this 2 to the RHS, and x equals minus 1 by 3. You got alpha equals 3 by 2 and beta equals minus 1 by 3. Next, what we have to find out? We have to find the relationship between zeros and the coefficient. To find the relation between the zeros and the coefficient, take first alpha plus beta. Alpha plus beta is 3 by 2 minus 1 by 3. Here you take the LCM. LCM is 6. Then 2 3 is 6 means 3 3 is 9 minus 3 2 is 6 means 1 2 is 2, which is equals to 7 by 6. Then you take alpha beta. Alpha beta is equals to 3 by 2 into minus 1 by 3. 3 3 cancels. Here 1 by 2 is the product. Consider this is first, this is second. Now you take the expression 6x square minus 7x minus 3. 6x square minus 7x minus 3. Write the values of ABC. A equals the coefficient of x square, that is 6. Coefficient of x, that is minus 7. B equals coefficient of x minus 7, and C is the constant minus 3. C equals minus 3. Then you take alpha plus beta in terms of the coefficient is minus b by a equals minus of minus 7 by 6. You got 7 by 6. Then alpha beta equals c by a. C is minus 3 by a is 6 equals 3 1s are 3 2s are minus 1 by 2. Consider this is the third one. This is the fourth one. Here you observe the first and third, alpha plus beta. You got the same. Therefore, you can write from first and third alpha plus beta is equals to minus b by a. And here you observe the second and fourth. Alpha beta is equals to c by e. Number 4. The graph of y equals p of x is given in the figure. Write the degree of this polynomial, identify its zeros and hence find the polynomial. Here the graph is given. To find the zeros, we have to verify the point of intersection of the graph with the x-axis. Here you observe 2 points. Find the x coordinate. This is 1, this is 2, this is 3, 4 and this is 0, minus 1, minus 2, minus 3. So the graph intersects the x-axis at 1 and minus 3. 1 and minus 3. So the zeros are 1 and minus 3. Then you write the answer. Zeros are 1 and minus 3. Next, find the polynomial. And also we have to write the degree of the polynomial. To find the degree of the polynomial, we have to find the number of points at which the graph intersects the x-axis. Here at 2 points the graph intersects the x-axis, so the degree is 2. Degree of the polynomial is 2. Then you write first one, degree of the polynomial 2. 2 zeros are there. It graph intersect the x-axis at 2 points. So the degree is 2. And also we have to find the polynomial. We got the degree. Degree of the polynomial is 2. We got the degree and the zeros. So you take first 0 is alpha. Alpha is equals to 1. Find alpha plus beta. Alpha plus beta is equals to 1 minus 3 equals minus 2. And alpha beta is equals to 1 into minus 3 equals minus 3. Then you write the quadratic polynomial x square minus alpha plus beta into x plus alpha beta equals x square minus alpha plus beta is minus 2 into x plus alpha beta is minus 3 equals x square minus of minus 2 is plus 2x minus 3. This is the. Now you take the model question paper 4. First one, the zeros of the polynomial p of x equals x square minus 3r. Here you write x square minus 3 and let x square minus 3 equals 0. Then x square equals 0 plus 3. So x square equals 3. Then x equals, here remove the square, in the RHS you will get root, that equals plus or minus root 3. So the roots are plus root 3 minus root 3. 3 minus root 3 minus root 3. Option B is the answer. Then you take the second question. Write the degree quadratic polynomial p of x whose zeros are alpha and beta. If alpha and beta are the zeros, then the quadratic polynomial is x square minus alpha plus beta into x plus alpha beta. This is the polynomial with the zeros alpha and beta. Next question, if alpha and beta are the two zeros of the polynomial p of x equals x square plus 3x plus 2, then find the value of alpha cube beta plus alpha beta cube. Here you take the expression x square plus 3x plus 2. Here you write the values of a, b, c, because we have to find the value of alpha cube beta plus alpha beta cube. To find this we need alpha plus beta and alpha beta. Therefore write the values of a, b, c. A is the coefficient of x square, a is equals to 1, and b is the coefficient of x, b is equals to 3, c is equals to 2. Then find alpha plus beta. Alpha plus beta is equals to minus b by a equals minus 3 by 1 equals minus 3. Then alpha beta is equals to c by a (2 by 1) equals 2. To find alpha cube beta plus alpha beta cube, alpha cube beta plus alpha beta cube, here you can remove alpha beta common, equals alpha beta into alpha square plus beta square. If alpha beta is removed outside, in the first term, here what is remaining? Alpha square is remaining, and here what is remaining? Beta square is remaining. You know the value of alpha beta, but to find alpha square plus beta square, use the identity alpha square plus beta square plus 2 alpha beta is equals to alpha plus beta whole square. You need alpha square plus beta square. So alpha square plus beta square equals what? Alpha plus beta whole square. Transfer this minus 2 alpha to the RHS, it becomes minus 2 alpha beta. This can be used here. Equals alpha beta into, in the place of alpha square plus beta square, you write this one. Alpha plus beta whole square minus 2 alpha beta. Now you put the value of alpha plus beta and alpha beta. Alpha beta is 2 into alpha plus beta is minus 3 whole square. Alpha plus beta whole square is minus 3 whole square. Minus 2 into alpha beta is 2 into 2. That equals 2 into minus 3 whole square is minus 3 into minus 3, 9. Minus 2 into 2 is 4. Equals 2 into 9 minus 4 is 5. 2 into 5 equals 10. Therefore you can write, therefore alpha cube beta plus alpha beta cube is equals to 10.